Hi and welcome to this video where we're going to see how to apply arrival tables in SIMIO model. Well, these arrival tables are very useful. For instance, if you want to model a situation like an airport where flights are arriving with a certain amount of passengers and you need to calculate the queues at the different stations or different servers of the airport. So now we start our SIMIO model and we simulate a passport control situation. So what we're going to do is to place a source. These are the arrival gates, and we write arrival gates as the name of the source. And then we're going to position a server. The server will contain different passport control check-ins. So we're going to call the server pass control. Okay, very good. We define pass control and we add in also a sink, which is the exit of the airport. So the passengers, they can go to a shop, they can go to pick up their bag. It's not very important. It's outside the boundary of the system we want to calculate. So we connect the output node to the input node of pass control, and here we connect pass control to the exit. Very good. So we can set some parameters related to this pass control server. For instance, let's say that we have 7 different booths and that the processing time will be in seconds. So we change the units of measure. We go from a minimum of 20 seconds to an average of 30 seconds and to a maximum of 50 seconds. So more or less, it's kind of realistic. So very good. So this is simple. Now we go and try to see how an entity can be drag and dropped inside the model. This is also very simple. From the bottom left corner, you drag and drop the green triangle. You call it a traveler and you assign to it, just for fun, an icon. And I will assign this time a special icon, this tune character. Well, let's take tune boy 1. So we add the traveler, visualize it in this way, and the model in 3 dimensions will look exactly like this. So now we add arrival tables. Why do we need an arrival table? Well, because passengers, they arrived in discrete slots. When a plane lands, a certain amount of passengers will move to passport controls with a little bit of delay. So we have a look at the arrival table now for this small airport. We have a call sign, we have the city where the plane is coming from, we have a date and time stamps, estimated arrival time, we have a time and date stamp aggregated, which is going to be very useful in SIMIO. We have amount of passengers exactly for that morning and a special property called a special property 1, which is a random triangular one. This represents the time it takes for all passengers to move from the arrival gate to the passport controls. And this is a random probabilistic distribution. So now we go inside again our SIMIO model. So we have to create a table, a data table. So we go under data, the data ribbon, we add a table and we call it arrival table. Yeah, not very creative. Anyway, it works. And now we need to create different columns corresponding to the data we want to import from the Excel file. So what do we want to import? We want to import the call sign, the city, and we want to import, in fact, the STD, date and time altogether. It's the only thing that works with SIMIO. And the passengers and this expression property. So we go inside the SIMIO again. So the call sign is in fact a string of characters and numbers. So we create a property which is a string property and we call it call sign. It's very important that the name of the column matches what you have in Excel. So we now add another string. This is the city. Also in this case it's very important that city is spelled correctly as in the Excel file. So we add the STD. This is a datetime property in SIMIO and it has to be formatted correctly in Excel too, otherwise it doesn't work. And then you have, yes, an integer, the number of passengers for each flight. And then we have to add the expression property 1. Essentially, when a plane lands, the minimum time it takes for a passenger to get to the passport controls is the first number of a random triangular distribution. And the maximum time is the third number. Now we create a binding to import the data. We go on the content, we click on create binding, we select the file. In this case, we take the file which is called airport example in my computer. We click on airport example, we click on open, And well, we close this pop-up window, and now we have created something which has no data in it because data has not been imported. We haven't said yet from where in the Excel file we import the data. Under worksheet or name range, we select this property is where the data is stored, and we import the table. You get the list, and you get also sometimes some artifacts. This is because I had the cells that were populated before. I cancelled and set everything to 0, but still they are imported in SIMIO. This is kind of a bug for the software. So if you get these strange artifacts, don't be worried. So now that you have a table, we go back to the facility view. We go to the arrival gate, and we change the arrival mode to arrival time. And it asks, okay, what is the arrival time property then? Time property is this std that we just imported from Excel, the time date stamp. Well, this is not enough to configure an arrival table. We also have to add 2 other properties related to arrival stream options. First of all, we have to select the right property for arrival events per time slot. This is the amount of passengers for a particular flight. And then there is some time deviation, which is in fact the function I was talking about before, this expression property 1. Not all 144 passengers are coming exactly the same moment, but there is some delay. So now if you run the model, we need to go under run and select the right date. All the data refer to the 14th of March 2023. And why is it 14th of March? Because it's the Pi Day, the day of the Greek pi. So this is something that we used very often as a date in our examples. We set it up to the 14th of March for 5 hours, starting from 6 o'clock. The first flight is at 6:25, yes. And we run the model. So now we are 601, we are at 602, it's going very slow, we accelerate it, and we expect some customers to pop up after the first flight is landing. So it's now 6:25, and now some passengers should arrive. I keep running the simulation and nothing is actually happening. Okay. Now I start to get worried. What can possibly have gone wrong? Well, where is something we need to fix? So I stop and pause the simulation. So what's the problem here? Is the unit of measure for the expression property. Why is that? Because by default, when you have an expression property in a table, this is set to hours. So what does it mean? Well, if you click on arrival gate and you see arrival time deviation, you have this arrival table dot expression property. But the expression property by default, if you really look into its property, is set in hours. So travelers will arrive after 7 hours, 14 hours. We need to set it to minutes. Otherwise, see, actually the model works, but you don't see the results because the passengers are so much delayed when they come to the passport controls. So let's see now. I run the model again. So it's 6:20 now. In a few minutes in the simulation, I should see my tunes going from arrival gate to pass control. And in fact, after for 7 minutes or so, what I was expecting is actually happening. So passengers are traveling and are going through passport controls. So it's going very quick, and we can also see that probably this is not quick enough because a long queue is forming, and this is totally expected. So this is the way arrival tables work and are very useful in many situations, especially in scheduling for manufacturing processes.